in this first set, we have that mathematicians are assigned a number called Erdos number, which has been named after the famous mathematician Paul Erdos. Only Paul Erdos himself has an Erdos number of 0. Any mathematician who has written a research paper with Erdos has an Erdos number of 1. For other mathematicians, the calculation of his/her Erdos number is illustrated below. Suppose that a mathematician X has co-authored papers with several other mathematicians. From among them, mathematician Y has the smallest Erdos number. Let the Erdos number of Y be Y. Then X has an Erdos number of Y plus 1. Hence, any mathematician with no co-authorship chain connected to Erdos has an Erdos number of infinity. So we can understand from this that someone who is not at all connected to Erdos in that chain of co-authorship will have an Erdos number of infinity. And if you have collaborated on a paper with Erdos himself, you will have an Erdos number of 1. Now, if you've collaborated with some person who has an Erdos number of 1, then you will have an Erdos number of 2. Okay, so your Erdos number will be 1 more than that. Then we have that in a 7-day long mini conference organized in memory of Paul Erdos. So that means that Erdos is no longer with us. He has passed away. So in this conference, a close group of 8 mathematicians, call them A, B, C, D, E, F, G, H, discussed some research problems. At the beginning of the conference, A was the only participant who had an infinite Erdos number. Nobody had an Erdos number less than that of F. So we have some information about the beginning of the conference, the situation right at the beginning before the conference started. And then we have some points of information. And we can see in these points, first of all, we have something about the third day of the conference. That on the third day, F is co-authoring a paper jointly with A and C. Okay, then at the end of the third day, there is a certain situation. After that, we also have some information about the 5th day. Okay, and then after that, it has been given, no other paper was written during the conference. So these are the things we have to focus on: the beginning of the conference, third day of the conference, and the 5th day of the conference. So let's get started. Okay, you can take a look at the questions if you want to. Try this set out and then look at the solution. So we will make a table in which we will have the names of the 8 people. We will have beginning of the conference, third day, 5th day. Okay, so it will be a very simple table like this based on the information that has been given. So let's start from the beginning. So it was given that at the beginning, A was the only participant who had an infinite Erdos number. So at the beginning of the conference, A's Erdos number was infinite. Then nobody had an Erdos number less than that of F, which means F had the minimum Erdos number at the beginning of the conference. So we can just mark it here, minimum. Also, A was the only participant with an infinite Erdos number. That means A must have had the maximum Erdos number, infinity. No one can have more than that. And A is the only one here. Okay, so this is what we can get about the beginning of the conference. If we move on the third day of the conference, F co-authored a paper jointly with A and C. Now, we don't know the Erdos number of any of these people. Okay, so let's assume the Erdos number. Let's take the Erdos number of F to be X. Now, if F has the minimum Erdos number, then whatever co-authorship F has with any other person, F's Erdos number will not change because F already has the minimum. The Erdos number of other people will change if they co-author with F because they will have a higher one. But as per the instructions given, F's Erdos number will remain the same because F already has the minimum one. So at the end of the third day also it will be X for F. At the end of the 5th day also it will be X. But now on the third day, F is co-authoring a paper jointly with A and C. This means that the Erdos number of A and C will become X plus 1. Okay, because F is the minimum. So if A and C co-author a paper with F, as per the instructions, their Erdos number will become X plus 1 at the end of the third day. So we can put that in the table. Then it has been given that this reduced the average Erdos number of the group of 8 mathematicians to 3 at the end of the third day. So if the average is 3 for 8 mathematicians, the sum will be 8 into 3, which is 24. The sum of the Erdos numbers of the 8 mathematicians at the end of the third day will be 24. Then we have been given that the Erdos numbers of B, D, E, G and H remained unchanged with the writing of this paper. Okay, so they were not involved in any co-authorship. Further, no other co-authorship among any 3 members would have reduced the average Erdos number of the group of 8 people to as low as 3. Let us think about this. So here what happened? A and C, they collaborated with F, and no other co-authorship would have reduced the average to as low as 3, which means we have reduced it by the maximum possible. Okay, we have reduced it as much as we can by this combination. So when will we get the maximum reduction? When we are taking the 2 people with the highest Erdos numbers. Okay, and then we are making them collaborate with F, who has the lowest Erdos number, and then these 2 people are getting an Erdos number 1 more than F. So these 2 people, A and C, they must have had the 2 highest Erdos numbers at the beginning of the conference. Now we know that A has the maximum with infinity. So C will have the second highest. Okay, so we can write it as second maximum, second highest. And we can just keep that in mind. That is the, let's say, inference from this particular point of information. And then we have another point about the third day. At the end of the third day, 5 members of this group had identical Erdos numbers, while the other 3 had Erdos numbers distinct from each other. Now, we don't have enough information right now to explore this, so we will come back to this later. Let's see what else is there. So now if you look at the information about the 5th day, on the 5th day, E co-authored a paper with F, which reduced the group's average Erdos number by 0.5. Now, F has the minimum, so if E co-authors with F, E's Erdos number will become x plus 1. Okay, so at the end of the 5th day, E's Erdos number will be x plus 1. And the Erdos numbers of the remaining 6 were unchanged with the writing of this paper. So A's Erdos number will remain the same, x plus 1. C's Erdos number will also remain the same, x plus 1. Anyway, we could have thought this because they were already collaborating with the person with the minimum Erdos number. So it couldn't have gone any lower. Okay, it will end at x plus 1 for them. And then it is given no other paper was written during the conference. So whatever is the situation we will get at the end of the 5th day, that will be the same situation at the end of the conference as well. Now we have one more thing here. The group's average was reduced by 0.5. So earlier it was 3. Now it is reducing by 0.5. So it is becoming 2.5 for 8 mathematicians. So the sum will be 8 into 2.5, which will be 20. Okay, so the sum of 24 is reducing to 20. That is a reduction of 4. How is that happening? Only because E's Erdos number is changing. No other Erdos number is changing on the 5th day. So E's Erdos number must be reducing by 4. So if it is x plus 1 here, it must have been 4 more than this. It must have been x plus 5. And therefore it must have been x plus 5 at the beginning of the conference also. Because before this, E did not have any other collaboration. So x plus 5 here also. Okay, so this is all the information that we have. Now we have to come back to that point about the third day. So if you look at this point again, at the end of the third day, 5 members of this group had identical Erdos numbers, while the other 3 had Erdos numbers distinct from each other. Now we will have to explore this. So what do we have so far for the situation at the end of the third day? We have that 2 people have x plus 1, 1 person has x plus 5, 1 person has x. Now we will get different possibilities. Let's start exploring. So there are 5 people who will have identical Erdos numbers at the end of the third day, and other 3 will have Erdos numbers which are distinct. Okay, now if we think about this possibility, that the 5 people to have identical Erdos numbers, the 5 people will have x plus 5 as the Erdos number. That is possible because we have 4 other people remaining, and these 4 other people can also have x plus 5. But the problem will be that we will not get that the other 3 will have distinct Erdos numbers, because from the other 3, 2 of them will have x plus 1, which will not be distinct. Okay, similarly, if we now think, can the 5 people with the same Erdos number, can they have Erdos number of x? Again, it will be the same problem. We'll get 5 people with Erdos numbers of x. Okay, so that part will be satisfied. But then this part of other 3 having distinct numbers, that will not be satisfied. We'll have 2 people with the same Erdos number. And if you think about this way, that one of the 5 people with identical Erdos numbers, the number will be something other than what we have right now. That will of course not be possible because we just have 4 empty spaces here. So we cannot have any other value. Okay, no other value can come 5 times now. We don't have that much space. And therefore, the only possibility is that the 5 people with identical Erdos numbers will have to have the Erdos number of x plus 1. Okay, so that we already have 2 people with x plus 1. 3 other people will have x plus 1. Then 1 person will have x plus 5, 1 person will have x. And 1 person will have some other Erdos number. Okay, so let us start using this. We can use this with the total of 24 that we have here. Okay, so 5 people will have x plus 1. 5 into x plus 1 will be the sum for these 5 people. Then 1 person will have x plus 5. Then 1 person will have x. Okay, so these are 7 people accounted for so far. And then the last person, we don't know what it will be. So just take a different variable y. And the sum here will be 24. So if we start solving this, we will get 5x plus x plus x, that will be 7x plus y. And on the left hand side, we'll get 5 plus 5, which will be 10. 24 minus 10 will be 14. So we are getting an equation in 2 variables. 7x plus y is 14. Now let's think about the possible values of x, since most of our information is in terms of x. Okay, and x has a coefficient of 7 also. Now, what are the possible values of x? What is the minimum possible value of x? Cannot be 0, because we have seen that Erdos has passed away. Okay, only Erdos himself had an Erdos number of 0. Okay, so x cannot be 0. So minimum it can be is 1. X can be minimum 1. Now when we put x is equal to 1, okay, then we will get that 7 plus y is 14. So that will give us y is equal to 7. This is valid. Nothing wrong with this. Will any other possibility work? If we try x is equal to 2, okay, then y will come out to be 0. Not possible, because Erdos has passed away. And if we try x is equal to 3 or any higher number, y will be negative, which is also not possible. And therefore, this is the only possibility that x will be 1 and y will be 7. Okay, so now we can start plugging in these values. Okay, but we will not use the same table now, because the problem will be that we'll get all the values. So if I write down the 8 values at the end of the 3rd day, we will have 5 values which are x plus 1. X is equal to 1. Okay, so x plus 1 will be 2. So we will have 5 values which are 2. 2, 2, 2, 2, 2. Okay, then we will have one value x plus 5. So 1 plus 5, which will be 6. One value which will be x, so that will be 1. And one value which will be y, which will be 7. So these will be the 8 Erdos numbers at the end of the 3rd day. Now the problem will be that we will know that A is 2, C is 2, E is 6, and F is 1. Okay, so we will have 2, 2, 6, 1. But what about the other 2s? What about the 7? Which people will have these Erdos numbers? We don't know. We don't know specifically. We know that B, D, G, H will have these 4 Erdos numbers. But which one of them will have 7? Which 3 will have 2? We have no information about that. So we will not be able to plug in these values in the table as it is currently. So let us make a new table now. And in the new table, let us not put in the people A to H. Okay, let us not limit ourselves to that. Let us keep it a bit open-ended. Now in this table, okay, we will start off with the people for which we know the information, we know the numbers, at least for 2 of the days. So we'll start off with A. For A at the beginning, infinite. At the end of the third day, x plus 1, so that will be 2. At the end of the fifth day, again 2. Then we'll look at we'll look at C. And C, we don't know the beginning one. We just know that it will be the second highest. Okay, end of third day, we know x plus 1, which is 2. End of fifth day, also 2. Then we know for E. So for E, at the beginning, x plus 5, which is 6. End of third day, also 6. And end of fifth day, it will become 2. Then we know for F, which is x throughout, so it will be 1, 1, 1. Okay, now for these values, which are values at the end of the third day, we have used up 2 2s, we have used up this 1, and we have used up this 6 here. Okay, so now what is remaining? 3 2s are remaining, 1 7 is remaining, so they will come here. Okay, we don't know which person from the remaining will get this 7, so we'll keep it open-ended. And these people, they never co-authored a paper in the conference, okay, because it was clearly given at the end. There was no other paper, no other co-authorship. And therefore, these people, their Erdos number never changed. It will only change if you do some co-authorship. Okay, so here, these people had the same Erdos number at the beginning and the same Erdos number at the end as well. And now one final deduction we can make is that at the beginning of the conference, C had the second highest Erdos number. So if you look at the beginning, highest is of course infinity by A. Okay, then the next highest right now is 7. So if C has to have the second highest, C has to be more than 7, greater than 7. So that is just something that we can mark here. And now with the help of this second table, we will answer the questions. So if you look at this first question, how many participants in the conference did not change their Erdos number during the conference? Okay, so we can clearly see F did not change his Erdos number, and similarly for these 4 other people. Okay, so we can see a total of 5 people did not change their Erdos number. Only 3 people, A, C, and E, changed their Erdos number. And to answer this question, we did not even have to solve everything. This was a question we could have solved, we could have answered without even putting pen to paper in 2 minutes, just by thinking that A, C, and E, they are the only ones who are co-authoring a paper with F. And F anyway has the minimum, so F's Erdos number will not change. So only the Erdos numbers of A, C, and E will change, which means it will not change for the other 5 people. And therefore, we could have easily marked option 4 as the correct answer. If you look at the next question, the person having the largest Erdos number at the end of the conference must have had Erdos number at that time. So if you look at the end of the conference, we know that whatever is the situation at the end of the 5th day, that is the same situation at the end of the conference. Okay, so here what is the largest Erdos number that we have? 7, and therefore the answer will be 7, option 2. If you look at this question now, how many participants had the same Erdos number at the beginning of the conference? So if you look at the beginning of the conference, we can see that 3 people had the same Erdos number, which is 2. All the other people had distinct Erdos numbers. And therefore, how many participants with the same Erdos number? 3 participants. So the answer will be 3, which is option 2. If you look at this question, the Erdos number of C at the end of the conference was, so very simply, we can see that the answer will be 2, which is there in option 2. And this question is that the Erdos number of E at the beginning of the conference was. So very clearly it is 6, which is there in option 3. Okay, this set, we have a games and tournament set, a round robin set, which of course is pretty important for the CAT. So let's take a look at it. The year was 2006. All the 6 teams in Pool A of World Cup Hockey play each other exactly once. Each win earns a team 3 points, a draw earns 1 point, and a loss earns 0 points. The 2 teams with the highest points qualify for the semi-finals. In case of a tie, the team with the highest goal difference, which is goals for minus goals against, qualifies. And then in the opening match, Spain lost to Germany. After the second round, which means after each team played 2 matches, the pool table looked as shown below. So this table that has been given us, this is only for the situation at the end of the second round, when everyone has played exactly 2 matches. Okay, but we know that overall, every team will play every other team exactly once, the round robin format. Okay, and we have some more information. We have some information about the third round. Okay, that these were the matches in the third round. All the third round matches were drawn. Okay, and then we have some information about the results from the fourth and fifth rounds. Now, how will we begin? We should also take a look at the questions to get an idea. So if you look at the questions, we can see that the first 2 questions are just about the first 2 rounds. Okay, and then the next 2 questions are about the further rounds with respect to qualification, for which all the rounds will take place. And after the 5 rounds of matches, so this is also all the rounds. And we should also remember that the table is only for the first 2 rounds. So in our solution, first we'll focus on the first 2 rounds. Okay, and we'll solve the first 2 questions. And then we will come to the additional information about the later rounds for the remaining 2 questions. So let's begin. Now in our solution, we know very well that in games and tournament sets where you have a round robin format, we use a particular kind of table where all the teams are in the rows and also in the columns. Okay, and we have that double entry system of capturing the data. Okay, so this table has been given in the information. Now the table that we will create in our solution will be this table, the standard round robin table, where you have all the teams in the rows, all the teams in the columns. Okay, and these crosses are of course because no team can play against itself. Germany cannot play against Germany, for example. Now we'll have to explore this. So how do we begin? Should we just look at the data in the table? Better way to get a starting point is to look at this extra information that in the opening match, okay, which is first round match, Spain lost to Germany. This is something extra for Spain and Germany. Okay, so let us start off with these countries. So if we look at Germany, we can see for Germany, out of the 2 games it has played, it has won both of the games. Okay, and we can see with respect to goals scored and goals scored against Germany, which is goals conceded by Germany. Germany has scored 3 goals in its 2 matches, and it has conceded 1 goal. So if you think about the possibilities, let us just note down the 2 matches of Germany. So this will be 1 match, okay, Germany against some other team, whatever the other team is. And this will be another match, okay, Germany against some other team. Now in one of these matches, Germany will concede 1 goal. Okay, Germany is only conceding 1 goal in total here. So in one of these matches, Germany will concede 1 goal. The other team will score 1 goal against Germany. But Germany will still win this match. Germany is winning both of the matches. So this match, if Germany is conceding 1 goal, it will have to score at least 2 goals to win the match. And now in the other match, okay, Germany will not concede any goal because it is just conceding 1 goal in total, which we already have here. So Germany will concede 0 goals here. Okay, and Germany will have to score minimum 1 goal here in order to win the match. And we can see that these minimum values, 2 and 1, minimum number of goals that Germany has to score in these matches, that is giving us the actual total of 3 goals. So there will be no other possibility. These are the 2 matches by Germany, 2-1 and 1-0. Okay, now, if we now look at Spain, we know that Spain lost to Germany in its opening match. Now we get cases. We get 2 cases that either this could have been the match, that Spain lost to Germany 2-1, okay, or this could have been the match that Spain lost to Germany 1-0. Now, we'll have to explore both of them. Okay, so let's start off with this first case, that this is the match that Spain is playing with Germany. Spain is scoring 1 goal, Germany is scoring 2 goals. So Spain is losing to Germany 1-2. Now, what can we do after this? See, this is just 1 match for Spain. Okay, so let us think about the other match for Spain. So we know that Spain has won 1 match and lost 1 match. Okay, now this is the match that Spain has lost against Germany. So the other match Spain will be winning. And if you look at the number of goals scored and conceded by Spain, Spain is scoring 5 goals in total in the 2 matches. Out of the 5 goals, 1 goal is here that Spain is scoring. So in the other match for Spain, Spain will be scoring 4 goals. So that 4 plus 1 will give us the total of 5. And also, Spain is conceding 2 goals in total. Out of the total 2 goals it is conceding, both of them are here. So it will be conceding 0 goals in this other match. Okay, so in this other match, Spain will be scoring 4 goals and the other team, the opponent, will be scoring 0 goals. Now let us think, this other match 4-0 can be against which team? Okay, it of course cannot be against Germany. Spain is already playing with Germany. Now, the important thing to focus on here is that Spain is scoring a large number of goals in this match, 4 goals. Okay, so the opponent is conceding 4 goals. And if you look at the goals conceded by the different teams, okay, there are only 2 teams which are conceding at least 4 goals. New Zealand is conceding 6 goals. South Africa is conceding 4 goals. Every other team is conceding less than 4 goals. Okay, so this opponent of Spain will be either New Zealand or South Africa. Now, can it be South Africa? See, if I put South Africa here, that South Africa is conceding 4 goals in this match, the problem will be that South Africa will not be able to concede any goals in its other match. It's already conceding all the 4 goals here. So it will not concede any goals in its second match. And that will be inconsistent with this data that South Africa is losing both of its matches. Okay, because if in the other match, if South Africa is not conceding even 1 goal, how can it lose the match? Okay, so this other team cannot be South Africa. And therefore, the only possibility is that this other team will have to be New Zealand. Now, if this is one match of New Zealand, where New Zealand is losing 0-4, what will be the other match of New Zealand? Okay, so New Zealand is scoring 1 goal in total. Now it has 0 goals here, so it will score 1 goal in this match. And it is conceding 6 goals in total, out of which 4 goals are here. So the other 2 goals will be in this other match. Now, let us think, this match of New Zealand, okay, where it is losing 1-2, whom can it be against? It cannot be against Germany. Okay, because 1-2 for Germany, that has already been taken up by Spain. Okay, this other match is 1-0, which of course cannot be this 1-2 with New Zealand. Okay, now of course, this 1-2 for New Zealand cannot be with Spain also, because Spain and New Zealand already have a match here. Okay, so it cannot be Germany, it cannot be Spain. Now, can it be Argentina? No, because we can see that Argentina is not even conceding 1 goal, it is conceding 0 goals. So if I put Argentina here, problem will be that Argentina will be conceding 1 goal, which will be inconsistent with the data. Okay, so we cannot have Argentina also. We can eliminate that. Can it be Pakistan? See, if I put Pakistan here, okay, then Pakistan is scoring 2 goals. Both of the 2 goals will be here. And Pakistan is conceding 1 goal. That 1 goal will be here. Which means in its other match, Pakistan's result will be 0-0. Okay, the other match that Pakistan will be playing, it will be 0-0 because 2-1 we already have here. Okay, but that will be inconsistent because Pakistan is also losing a match. Okay, no one is drawing a match. Therefore, this cannot be Pakistan also that New Zealand is playing against. And now the only possibility is South Africa. Okay, so if I put South Africa here, again the inconsistency is that South Africa is only scoring 1 goal. Whereas here, South Africa will be scoring 2 goals. And therefore, this team against New Zealand cannot be South Africa also. And therefore, we can see that there is no possibility, there is no possible opponent for New Zealand in this match. Every other team has been eliminated as a possibility, and therefore, this case is invalid. Our initial assumption that this is the match between Germany and Spain, this is turning out to be invalid, because we are not getting any possible opponent for New Zealand here in this match. Now, if this case is invalid, the only other case will have to be valid, that the match between Germany and Spain will be this match, which Spain is losing 0-1. Okay, so let's continue with this now. This has to be the correct case. So if you look at Spain's other match, now in this match, Spain is scoring 0 goals. Okay, but we know that overall it is scoring 5 goals. So in this other match, Spain has to score 5 goals. And we know that Spain is conceding 2 goals in total, out of which 1 goal is here. So 1 more goal has to be conceded by Spain in this other match for the total of 2. Okay, so this will be the other match of Spain where Spain is scoring 5 goals. Now, along similar lines of logic, we have to think, because 5 is a large number, okay, we have to think whom can this match be against with Spain. Okay, so if we look at the goals conceded again, we can see that it has to be New Zealand. Only New Zealand is scoring at least 5 goals in total. Conceding at least 5 goals in total. No other team is. So this has to be New Zealand, where New Zealand is conceding 5 goals. And therefore, in its other match, New Zealand will be conceding 1 more goal. New Zealand is conceding 6 goals in total. 5 are here. So 1 more will be here for a total of 6. And New Zealand is scoring just 1 goal in total. That 1 goal is already here. Okay, so New Zealand will be scoring 0 goals in this other match. So now we have these 2 matches of New Zealand also. We have 2 matches of Spain also. We have 2 matches of Germany also. Okay, so now we'll look at the matches of Argentina, Pakistan and South Africa. Now if you look at Argentina's matches, Argentina's 2 matches, keep in mind that there might be some overlap. For example, this match of New Zealand might be a match against Argentina. Okay, so it might be an overlap, but it is a good idea to explore the matches of all the different teams separately and combine whenever we are getting something for certain. So if you look at Argentina's 2 matches, Argentina is scoring 2 goals in total, conceding 0 goals in total. Okay, so both of these matches, Argentina will be conceding 0 goals. And now, Argentina is winning both of these matches by scoring 2 goals in total. So both of these matches, Argentina will be scoring 1 goal each. Okay, and that is how we will get that Argentina is winning 2 matches by scoring 2 goals and conceding 0 goals. Now, we can see that this match of New Zealand can be a match with Argentina. Okay, but we cannot just assume it right now. Let's try to explore a bit more. So if we now look at Pakistan, okay, if we look at Pakistan now, the 2 matches, Pakistan is winning 1 match, losing 1 match. It is scoring 2 goals in total and conceding just 1 goal in total. Now, if it is losing 1 match, okay, then that has to be the match where it is conceding 1 goal. And in that match, Pakistan must be scoring 0 goals. Okay, that is how it will be losing this match. And now, in the other match, therefore, it will be winning. And it will be winning by scoring 2 goals. So the other match will be 2-0. Okay, now that we have these matches, we can see that we have the 2 matches of Germany, we have the 2 matches of Spain, 2 matches of New Zealand, 2 matches of Argentina, 2 matches of Pakistan. Now we just have to think about the 2 matches of South Africa. Okay, but here we have 1 and 4 for South Africa, which will give us multiple possibilities. Okay, so instead of that, let us just think about the matches we have so far and think about what are the possibilities for the opponents. For example, in this match, who could be the opponent of Germany? Okay, so why are we looking at this match? Because, for example, for this match 0-1, it could be Argentina. There is a possibility, even though we cannot guarantee it right now. Okay, but if we look at this 2-1, we don't have 2-1 anywhere else here. So this 2-1 match for Germany, it cannot be against Spain, cannot be against New Zealand, cannot be against Argentina, cannot be against Pakistan. Okay, because for these other teams, we don't have 1-2 for them in any match. And therefore, if it cannot be against these teams, then the only possibility is that it will have to be against South Africa. Okay, so Germany will be winning this match 2-1 against South Africa. And therefore, South Africa's other match. See, South Africa is conceding 4 goals in total. Okay, so out of the 4 goals, 2 goals it will be conceding here. Other 2 goals it will be conceding in its other match. And also, South Africa is scoring 1 goal in total, which is already here in this match. So in this other match, it will be scoring 0 goals. Now we have all the matches. We can start connecting. For example, this 0-2 that we have with South Africa, it will have to be with this 2-0 against Pakistan. Okay, so we can just note that here. And this is Pakistan, this is South Africa. And similarly, now this 0-1 for New Zealand, it will have to be against Argentina. No other possibility. And similarly, this 1-0 with Argentina has to be against Pakistan. Okay, so now we can start entering all of this information in our table. Okay, so starting with this match, Germany won against South Africa, W for 1, and it won 2-1. Now, this also means from the other perspective, from South Africa's perspective, that South Africa lost this match against Germany and South Africa lost 1-2. Okay, this is what I mean by the double entry system. Now, we have this match. Germany won against Spain 1-0. So, Germany won 1-0 against Spain, and therefore Spain lost against Germany 0-1. Okay, so we have the two matches of Germany. Germany is done. Now, we have this match of Spain. Spain won against New Zealand 5-1. So, Spain won here 5-1 against New Zealand, and therefore New Zealand lost against Spain 1-5. Okay, now we have the two matches of Spain also here. Next, we have this match of New Zealand. New Zealand lost against Argentina 0-1. So, New Zealand is losing here 0-1 against Argentina, which means Argentina is winning here against New Zealand 1-0. Okay, so now we have the two matches of New Zealand also. Now, we have this match remaining of Argentina. Argentina winning against Pakistan 1-0. So, Argentina is winning 1-0, and therefore Pakistan is losing against Argentina 0-1. Now we have the two matches of Argentina as well. Okay, now the only match remaining is the match between Pakistan and South Africa. Okay, so Pakistan is winning this match 2-0, and South Africa is therefore losing this match 0-2. And now we have been able to find the results of all the two matches in the first two rounds of the tournaments. Okay, so we can answer the first two questions now. So if you look at the first question, which one of the following statements is true about matches played in the first two rounds? So if you look at the first option, Germany beat New Zealand by 1-0. Germany is not even playing against New Zealand in the first two rounds. So this is not correct. Second option, Spain beat New Zealand 4-0. No, Spain is beating New Zealand 5-1. So second option is also not correct. Third option, Spain beat South Africa 2-0. Okay, we can see Spain is not even playing against South Africa. So not correct. And fourth option, Germany beat South Africa 2-1. This has to be correct now. We can see it here. And therefore, the correct option will be option 4. If you look at this question, which one of the following statements is true about matches played in the first two rounds? First option, Pakistan beat South Africa by 2-1. So we can see Pakistan is beating South Africa, but by 2-0. So first option is not correct. Second option, Argentina beat Pakistan by 1-0. And we can see that that is definitely true. And therefore the answer will be option 2. Now in the next question, this question we have to explore further about the further rounds, because it was given that the top two teams will qualify at the end of the 5 rounds. They will go to the semi-finals. So here the question is asking if Pakistan qualified as one of the two teams from Pool A, which was the other team that qualified. Again, this will be the situation at the end of the 5 rounds when all the teams have played against all the other teams, where every team has played against every other team exactly once. Now, there is actually a problem with the information regarding these further rounds and therefore a problem with these last two questions. Okay, so if we look at the problem is that it has been given that in this information about the 5th round matches, that Spain won its 5th round match. Okay, Spain is winning its match in the 5th round. Argentina and Germany, both of these are also winning their matches in the 5th round. And then Pakistan is also winning its match in the 5th round. So we have a total of 4 teams winning their matches in the 5th round. But in every round, how many matches are there? 3 matches are there. Because there are 6 teams in total. Okay, and in one match, there will be 2 teams. Okay, so in every round, there will be a total of 3 matches. 2 teams, 2 teams, 2 teams. 3 matches will be there. Now, if there are 3 matches in the 5th round, 3 matches in every round. So in the 3 matches in the 5th round, we can maximum have 3 winners. How can there be 4 winners? And therefore, this was an inconsistent data, which means this question ideally should not have been attempted only. And what would have happened if the objection was raised and the objection was accepted, which it should have been, at least in the current scenario, in current years, we have the option of raising an objection and they will review it. And if it is found to be valid, okay, for example, this question would have been scrapped and maybe everyone would have gotten the marks. So they would have done some adjustment. Okay, so we wouldn't have had to worry about that. That adjustment would have been taken care of by the authorities. But the point is that if you come across such a situation where the data is inconsistent, then better it is to leave it and to raise an objection after the CAT. And similarly, if you look at the next question, okay, here also it is about the which team finished at the top of the pool after 5 rounds of matches. Again, we cannot answer this question because of the inconsistent data, that 4 teams are winning in round 5, okay, but there are only 3 matches in round 5. So how can 4 teams win? And therefore, these last 2 questions should not have been attempted. So why am I showing you this set if the last 2 questions have this inconsistent data? Because the first 2 questions and the table that was related to the first 2 rounds, okay, that is still very good practice for games and tournaments, especially these round robin sets, which we know are still important in the CAT. Okay, so overall, still very good practice for the first 2 questions. Okay, in this set, we have been given that there are 21 participants from 4 continents, Africa, America, Australasia, Europe. And these participants attended a United Nations conference. Each participant was an expert in one of 4 fields. Fields are labor, health, population studies, refugee relocation. The following 5 facts about the participants are given. Okay, so we have that the number of labor experts in the camp was exactly half the number of experts in each of the other 3 categories. Africa did not send any labor expert. Otherwise, every continent, including Africa, sent at least 1 expert for each category. Then none of the continents sent more than 3 experts in any category. Then if there had been 1 less Australasian expert, then the Americas would have had twice as many experts as each of the other continents. And finally, Mike and Alfonso are leading experts of population studies who attended the conference. They are from Australasia. Okay, so when we look at the information, if you've practiced enough DILR, you should be able to see that this is a fairly easy, manageable set. What kind of a table will we make to capture the data? Okay, we'll think about the broad categories that we have 4 continents, we have 4 different categories, 4 different fields, and therefore we will make a table with, let's say, the continents in the columns and the 4 different categories in the rows. Okay, so that will be a very simple table. So overall seems like a fairly manageable set. Okay, now the only thing here will be that the questions might take a little bit of time to solve. Okay, because every question, or at least most of the questions are something like, which of the following is not possible, which of the following is not true. So we'll have to go option by option. So let's get started with the solution. Okay, so the table that we will make, as I said, will be this kind of a table where the broad categories of continents are in the columns and the fields are in the rows. Okay, so now which point of information should we start off with? So here it doesn't matter that much because there are only 5 points and it is not a very difficult set. But still, it's a good idea to develop the habit of using the information in the best possible order. So we'll start off with the broader conditions. Okay, now the categories are about the continents and the different fields. Okay, so let us look at the points of information which are, let's say, comparing all the continents or comparing all the fields. Okay, so that they are talking about either all the continents or all the fields. So if you look at condition A, point A, the number of labor experts in the camp was exactly half the number of experts in each of the other 3 categories. So if I take the number of labor experts to be X, the number of experts in each of the other 3 categories will be 2X. Okay, that is how we will get that labor experts will be half of each of the others. Now we can use the initial data, which is that there were 21 participants in total. Okay, so here the overall total is 21. So that will give us that X plus 2X plus 2X plus 2X is 21, which means 7X is 21, and therefore X is equal to 3. And therefore 2X will be 6. Okay, so we can find the totals of the 4 different fields. That total there are 3 labor experts, 6 health experts, and so on. Okay, now we can remove this X. And similarly now we will look at the continents. So the relevant point is point D. Okay, because it is talking about all the continents. Okay, Australasia, America, and even the other continents. So this condition is saying that if there had been one less Australasian expert, then the Americas would have had twice as many experts as each of the other continents. Now let us look at that situation if there had been one less Australasian expert. Then the condition is saying Americas would have had twice double the number of experts as each of the other continents. So if I give America 2y here, then each of the other continents would have had y. Okay, that is how America would have had twice the number as each of the other continents. Okay, but this would have been the situation if there had been one less Australasian expert. Okay, so the actual number of Australasian experts is not y. It will actually be y plus 1. Okay, again, this was the, when we had y here, that was the situation when America would have had twice as many experts as each of the other continents. And in that situation, we were reducing the number of Australian experts by 1. Okay, we were taking one less than the actual number of Australasian experts. Therefore, the actual number of Australasian experts is y plus 1. And now we can solve this to get the value of y. Y plus 2y plus y plus 1 plus y, that is equal to 21. Okay, so we'll get that 5y plus 1 is equal to 21. So 5y will be 20 and y will be equal to 4. So we can start filling in these values. Okay, y is equal to 4, 2y is 8, y plus 1 will be 4 plus 1, 5. Okay, and y will simply be 4. And now we can remove the y terms. Okay, because we have found the numbers. So we have at least the individual totals of all the different categories. And now we can come to the other points of information. So this is also a broad condition, condition C, that none of the continents sent more than 3 experts in any category. Okay, which means that for all the missing values, each missing value can be maximum 3. We cannot have more than 3 experts in any category from any continent. Okay, so now we simply have 2 other points to look at. So if you look at point B, Africa did not send any labor expert. So from Africa, we had 0 labor experts. Otherwise, every continent, including Africa, sent at least 1 expert for each category. Okay, which means all the other values in the table, all the missing values in the table, all of them will be at least 1. Okay, and all of them will be maximum 3. So we'll keep that in mind that all of the other numbers in the table, they can either be 1, 2 or 3. Minimum 1, maximum 3. Okay, now using this, we can see that in labor, total is 3. And each of these 3 values in labor, all of them will have at least 1 expert. And therefore, the only possibility is 1, 1, 1. That is how all of them will have at least 1 and we will get the total of 3. Similarly, now if you look at for the total for Europe, the total is 4. Okay, so the only way to get that is that if all of these 4 values are 1, that is the only way in which all of them will be at least 1 and we will get the total of 4. So these will be 1, 1, 1, 1. And now we come to the last point. Mike and Alfonso are leading experts of population studies who attended the conference. They are from Australasia. So this is telling us that from Australasia, we have at least 2 people who are attending the conference with respect to population studies. And therefore, Australasia and population studies will be either 2 or 3. It cannot be 1 because we have 2 people, Mike, Alfonso. So it can be 2, okay, but there might be 1 more person also who has not been named here. So we'll consider the possibility of 3. Now if we explore 3, that if we have 3 people here, the problem will be that we have 2 other values in this column for Australasia. Both of these 2 values will be at least 1. Okay, but then the total will become more than 5. Because here already we have 3 and 1, which is 4. And other 2 values will be at least 1. So total will become at least 6, which is inconsistent because here we have exactly 5. And therefore, we cannot have 3 here. We cannot have 3 population studies experts from Australasia. So it will have to be exactly 2. Okay, Mike and Alfonso will have to be the only 2 population studies experts from Australasia. And continuing with that, the total is 5 here. We have 2 plus 1, which is already 3. So the other 2 values will have to be exactly 1. So that we get a total of 5 and all the values are at least 1. Now, we have used up all the points of information. Okay, can we find any of these remaining values? Okay, we will see that we cannot because, for example, here the total is 8. Okay, so there are multiple ways of getting the total of 8 from these missing values in the column. Similarly, from the total of 4, we have multiple possibilities for these 3 values. Okay, we will get 2, 1, 1, but which one of them will be 2? We don't know. And similarly, if you look at the rows also, for example, the total here is 6, out of which we just have 1 and 1. 4 is remaining. Multiple combinations are possible for the 2 remaining values. So this is all that we can find. Okay, and now we will have to come to the questions. So looking at the first question, which of the following combinations is not possible? We'll have to go option by option. If you look at the first option, 2 experts in population studies from the Americas. Okay, so from America, we have 2 in population studies and 2 health experts from Africa. 2 health experts from Africa. Now let's use this to find the missing values for this situation. So for Africa, total is 4. We already have 2. So the remaining values will be 1 and 1. Okay, now for example, health total is 6, out of which we have 4 until now. So the remaining will be 2. Similarly, for example, America, the total is 8, out of which we have 5 so far. So this remaining will be 3. Okay, and this we will see that refugee relocation total of 6, that is being satisfied here. So there is nothing wrong with this combination. All the totals are being satisfied. Okay, so this one is possible. Question is asking for what is not possible. So option 1 is not the correct option. If you look at option 2, 2 experts in population studies from the Americas. Okay, 2 here and 1 health expert from Africa. Okay, let's see if this is possible. So if we have 2, 2, 1 in population studies, that's 5 out of 6, which means 1 will be remaining here. Okay, remaining 1 will come here. And now total for Africa is 4, out of which we have 1, 1, which is 2. So the remaining 2 will come here. Okay, and then we can see for refugee relocation total 6, out of which we have 2, 1, 1, which is 4. So the remaining 2 will come here. And similarly, now we know total for America is 8, out of which we have 5 so far. So the remaining 3 will come here. And this 3 with 1 plus 1 plus 1, that will give us this total of 6. So there is no inconsistency. This is perfectly possible. Okay, therefore this is not the correct option. So let's move on to the third option. So in the third option, we have 3 experts in refugee relocation from the Americas. 3 here. And 1 health expert from Africa. Okay, let's see if this is possible. So if we have in refugee relocation, we have 3, 1, 1. Okay, 3, 1, 1 is 5. We will have 1 more here to get the total of 6. And now for Africa, total is 4. We have 1, 1 already. So remaining 2 will come here for the total of 4. Okay, now in population studies, we have 2, 2, 1, which is 5 out of 6. So remaining 1 will come here. And similarly, for health, we have 1, 1, 1, which is 3 out of 6. So remaining 3 will come here. And now we can see that the total for America is being satisfied. 1, 3, 1, 3, that is a total of 8. So there is no inconsistency here also. Third option is also possible. Okay, so now we can directly mark the fourth option because we have eliminated the other 3 options. But still, let's take a look at it. So fourth option is that Africa and America each had 1 expert in population studies. So Africa had 1 expert in population, America also 1 expert. And very clearly this is incorrect, this is inconsistent, because for population studies, we are only getting 1 plus 1 plus 2 plus 1, okay, which is 5, but the total should be 6. And therefore, this is not possible. Therefore, option 4 is the correct option. If you look at this question now, it has been given that if Ramos is the lone American expert in population studies, which of the following is not true? about the number of experts in the conference from the 4 continents. So let's use the additional information that is specific to this question, that Ramos is the lone. Lone means the only one. Okay, so Ramos is the only American expert in population studies. So America has only one expert in population studies. Okay, now using this, the total for America is 8, out of which we have 1 and 1, which is 2. So out of 8, we have 2, 6 is remaining. Okay, now for the remaining 6, the only possibility will be 3 and 3 here. Okay, because the maximum possible is 3. So we will have 3 and 3. That's the only way we will get 8 here. Now we can find the missing values. For example, health total is 6, out of which we have 3, 1, 1, which is 5. So remaining 1 will come here. Similarly, we can see that for population studies, we have 1, 2, 1, which is 4 out of 6. So remaining 2 will come here. And similarly, for refugee relocation, we have 3, 1, 1, 5 out of 6. So remaining 1 will come here. Okay, so we can find everything as per this extra information in this question. Now, if we look at the options and try to find the option which is not true. The first option, there is one expert in health from Africa. Okay, we can see yes, that is true. So this is not the correct option. Next option, there is one expert in refugee relocation from Africa. We can see that that is also true. So that is also not the correct option. Next option, there are 2 experts in health from the Americas. Okay, that is definitely incorrect because we can see that there are 3 experts in health from Americas. And therefore, option 3 will be the correct option. In this question, it has been given that Alex, an American expert in refugee relocation, was the first keynote speaker in the conference. What can be inferred about the number of American experts in refugee relocation in the conference, excluding Alex? So here we know that Alex is an American expert in refugee relocation. Now we have to think, is it possible for Alex to be the only American expert in refugee relocation? Or can there be other ones also? So let's try out the possibilities. If we make Alex the only one, then America will just have one expert in refugee relocation, which will be Alex. Okay. Now, what will we get? That these are 1 in refugee, 1, 1, 1, which is 3, 3 out of 6. Okay, 3 out of 6, and therefore the remaining 3 will come here. And now see the problem, in Africa total is 4, out of which we will have 3 here. So only 1 will be remaining. Okay, but these 2 missing values, both of them have to be at least 1. Okay, so we will not be able to satisfy that. If we give one of them 1, other one will have to be 0, which will not be valid as per the information. And therefore we can see that this situation, okay, where Alex is the only American expert here in refugee relocation, this is not valid. So there has to be at least one other person. Excluding Alex, apart from Alex, there has to be at least one other person here. Okay, therefore this statement that we will have at least one other person, this is true. Okay, now, so we'll definitely have at least one more. Okay, we can have 2. Okay, 1 will be Alex, 1 will be another person. Now we have to think, because we have this option at most 2 other people. Now we have to think, can we have 3 people here in total? Alex and 2 other people. So if we have 3, 1, 1, which is 5 out of 6, remaining 1 will come here. Okay, now, here the total is 4, out of which we have 1. 3 is remaining. Okay, we can have either 2, 1 here, or we can have 1, 2 here. Okay, let's look at any one of them. See whether this situation is possible. So if we, for example, look at this 1, 2, then for health, out of total 6, we have 1, 1, 1, which is 3. So remaining 3 will come here. And then for America, out of total 8, we have 7 so far. So remaining 1 will come here. Okay, and for population, the total will be satisfied. 2 plus 1 plus 2 plus 1, which will be 6. So we can see that this is also possible, that we can have total 3 people here, which means Alex and 2 other people. So it is also possible to have 2 other people, and that will be the maximum, because the maximum can be 3. And therefore, this is also possible, this is also true. So we can see that both 1 and 2 are true, which is captured in option 3. Now in this question, which of the following numbers cannot be determined from the information given? Now before even looking at the options, let's get an idea of which values we couldn't find out. So we can see we couldn't find out these values. Now these values are for Africa and America, okay, and they are for health, population studies and refugee relocation. So we will look at the similar options, related options. For example, we can eliminate option 2 because that is for Europe and we have been able to find everything for Europe. We can eliminate option 3. We have been able to find everything for Australasia. And similarly, we can eliminate option 1 because we have been able to find everything for labor experts. And therefore, answer will be option 4 because it is talking about number of experts, refugee relocation from Africa, which is this value, which we have not been able to find. And therefore, the correct answer is option 4.